I don't know if everybody knows that song or not. That's an old song from George Harrison from the Beatles called My Sweet Lord. Just goofing around a little bit there. All right, so I think I've got maybe my computer working again. I've been messing around with this for the whole evening trying to get this going, so I'm going to see if this works out. All right, so we're going to do a video on the algebra of vectors. Scalar multiplication is where we're going to start. All right, so I've already shown you scalar multiplication. So I think we're going to do two things. I'm going to do this vector first of all, and we're going to go ahead and sketch that vector to begin with in this first thing. So let's go ahead and do that. So anyway, this vector is left 3, down 4. So you want to go ahead and get that put together. All right, then I'll show you what we do with the scalar multiplication, which we have talked about. We just hadn't done it, I think, algebraically. We have done it graphically, though. All right, so to begin with, let's go down here, and we're going to do this, negative 2v. So if we do negative 2 times that vector, then we're taking negative 2 times the vector we just graphed, like this. So just think of this like a distributive property. That's what you're doing. So that would be 6i. And this would be plus 8j, okay? And we're going to go ahead and plot this out, and I'll show you what this means then. So this just means we go over 6, and we go up 8, like that. And then I'd like you to go ahead and sketch out that vector, okay? And we'll talk about what that is doing then. All right, so what it did was it did two things, okay? It changed the direction, and it also doubled the length. Okay, so that negative changes the direction, okay, like you would expect, but then the 2, of course, doubles the length. Okay, so that's how that goes. All right, so let's see. Next thing we're going to do is over here, we're going to plot, let's plot out this vector, and this is written in a different form, still means negative I plus 2j, so we go left 1 and then up 2 like that. So let's go ahead and sketch that vector. All right, so that will go like this. Okay, now what we're going to do is, I'll do this in a different color, we're going to do 3w. Okay, so we're going to take 3 times, and you can use this same notation when you do this. You can do this like this if you want to. So that would be 3 times negative 1 would be negative 3. 3 times 2 would be 6. So we're going to sketch that vector. So we would go left 3, up 6. And then if we go through and sketch that, what I want you to see is what happens and what the mathematical meaning of that scalar multiplication is then. So actually, if you look at this, what happened is it's the same direction. And that's because you're multiplying by a positive number. And it's 3 times longer. Okay, so that's what that basically did on that. So that's how you do scalar multiplication algebraically. It's real simple, just multiply the vector by the scalar, like doing a distributive property. Okay, next page here, vector addition and subtractions, another real simple thing to do. You can kind of think of this as adding like terms. So if you had 2 vectors, if you had a vector AI plus bj and another vector ci plus dj, you just add the I components, A and C, you add the j components, B and D, like that, okay? And you can write it in this form also. Same thing with vector subtraction. Vector subtraction, you just did go A minus C, I, and then plus B minus dj, like that. Okay, real simple thing to do. All right, so what we want to do with this one is, on this one, we're going to go ahead and do this. We're going to, on this, we're going to do u plus v. So let's write down vector u. That is 2i plus 4j. And then we're going to add to that vector v, which is 3i minus j, like this then. Okay, now what I'm going to go ahead and do is have you plot those two vectors. Okay, so we have 2i plus 4j. So that vector is going to go like that. Okay, the second vector is 3i minus j, so that would be over 3 down 1. So the second vector will go like that. Okay, now let's go ahead and let's put this together. So we just add these like terms. So we're really doing 2 plus 3i is 5i. Then we're doing 4 plus negative 1, which will be plus 3j. All right, so let's see. All right, go ahead and plot that. So go over 5, up 3, like that, and let's see if that makes sense. Okay, remember when we learned how to do this earlier, we did this sort of tip-to-tip method. So like if you can imagine in your mind moving this vector over here, then you would end up having that resultant. Okay, so it's very easy to do this algebraically. All right. Okay, so let's see. So that would be the answer would be looking for on that then. All right, and that's the graphical thing. All right, the next one, let's see. We have vector v is 3i minus j. Okay, that's given here. And then we're going to subtract vector w, which is negative I plus 2j. Okay, and what I'll do on this, I'll write this out. It's just like what you're used to doing in algebra when you are subtracting a quantity. That's changing those signs. So that'll be minus minus I, so that becomes plus I, and then minus 2j like that. Okay, if you put together the like terms, those go together, and the j's go together. Okay, so when you do that, you would have 4i and minus 3j. Right, so the answer to that vector subtraction is that. So what I'm going to have you do on this is, again, we're going to go through and graph the two original vectors. So this first vector is over 3 down 1. So 3i minus j will be that vector. Okay, and then the second vector is negative I plus 2j. So you want to go ahead and sketch that one. So that would mean you would go left 1, up 2. So that would be your second vector. So this is your vector v, that's your vector w. And then we'll do the resultant and just see if this looks right to us. All right, so let's see. All right, so this one we're going to go right 4, down 3. So if we go right 4 down 3, we would end up there, and that would be vector v minus w like that. Okay, well, if you remember this, what we did and what we learned how to do is we learned to write this v minus w as v plus negative w. So when you do negative w, it changes the direction. So this thing would be, instead of going left 1 up 2, it'd be right 1 down 2. So if we change the direction of that vector, it'd be going like that. And then you can kind of see this thing's going in the middle of those two right there. All right. So the answer of that would be 4i minus 3j. All right, let's see. Let's do one other one here. And let's see, on this one, let's write down what we have. So vector u is 2i plus 4j. And in this problem, we're going to multiply that by the scalar 2, then minus, and then we're going to take vector w, which is negative I plus 2j, and going to multiply that by 3. Okay, so we're taking 2 times vector u minus 3 times vector w. Okay, well, let's go ahead and let's work that out then. So you do a distributive property, so that would be 4i plus 8j, that's your scalar multiplication. And you can go ahead and do this like this if you want to. Negative times negative would be plus 3i. Negative times positive would be negative 6j. Okay, then you can put together your like terms. So put the i's together, put the j's together. And let's see, 4 plus 3 would be 7i. 8 minus 6 would be plus 2j. So that should be the vector result on that. Okay? And this one's a little bit harder to see maybe, but I'm going to have you just graph the original vector. So we're going to do these two vectors right here. Okay, so we've got, for the first one, we're just going to plot out 2i plus 4j. So go over 2, up 4. Okay, that would be your first vector. And for the second one, let's do negative I plus 2j. So that would be left and then up. So that one will go like that. Okay. Well, what happens on this is we multiplied these things by a scalar. So what I want you to do next is this. Okay, do this vector, 4i plus 8j. So now we're going to go over 4, up 8. So over 4, up 8. Gosh, this is so hard to see. Okay, there we go. Okay, so that vector doubled in length. Okay, then what I'm going to have you do is this vector, 3i minus 6j. So that's when we basically multiplied by that scalar negative 3. So this one we're going to do is go over 3, down 6. Okay, so I think I'm getting that right. There we go. Okay. All right, what did that do? It tripled the length and changed the direction. So we have that. All right. Now what we're going to do is we're going to do the resultant. So I'll pick a different color and do the resultant then. Okay, so we go over 7, up 2. All right, and that's pretty logical. Okay. Right in the middle. Okay, that resultant of those two vectors is right in the middle like that. Okay, because really what we did is we changed this to an addition problem. All right. Okay, so it's real easy to do that. The reason I'm having you graph these out is to help you make sense of the geometry of it. But if you don't have to do the geometry and the graphing, there's nothing to it. So students never have any trouble doing this. Okay, I don't think anyway. All right, so go to the next page. So let's go ahead and do this. And then this video, we're going to do this and the dot product together because it's relatively short. Okay, so go ahead and pause the video and let's do these. Okay, so let's check these over and see how you did. I am going to just stop this video after this because I kind of like doing videos that are just particular to one subject. So just Algebra of Vectors. So this one you should got 5-3. Okay, and you can just use this. To me, it's a lot easier to use this notation than to have to write those IJs all the time. So you should have got 2 plus 3 is 5, 2 plus 1 is 3. The graph goes like this. The very first graph is over 2, up 2. So that would be vector u. Then the other one is over 3, up 1. So that would be vector v. And then the one in the middle is the 5-3. Okay, whenever you add vectors, you can kind of think of this as a resultant force. I like to think of it like, okay, you got a pool ball, somebody's hitting it that way, somebody's hitting it that way. The ball's going to kind of go somewhere in that direction in between those two then. All right, so that path of that pool ball would kind of go something like that. All right. Okay, the second one now, and you don't have to write your steps exactly the way I do. I'm just trying to teach students to be careful about this. So the first vector is 3, 1. The second vector is negative 2, negative 4, and you're subtracting. And you can do this in your head. Okay, I'm going to bring 3, 1 down. I change this to plus a negative times that, then bring that scalar through. So when I do that, I would have positive 2, positive 4. So I just end up adding those two vectors, so I get 5, 5. With this one, let's see. The first vector, v, is 3, 1. The second vector is -2, -4. All right, and then the resultant is this. All right, now one thing on this one that you got to kind of see that I want you to try to see on this is if you have v minus w, that's really v plus -w. Well, in your mind, just kind of think about the way I taught you geometrically. This thing is left 2 down 4, so the opposite of that's over 2 up 4. So really that you would be changing the direction of that. And then you can see that resultant goes right in the middle of those two like that. Okay. All right. The next one's hard to see because it's kind of out of room on the graph. But anyway, you should have got 10, 14. Multiply the first vector 2, 2 by the scalar 3. Multiply the second vector -2, -4 by the scalar 2, and then subtract. So this would be 6, 6. This would be, the way I did this is I brought the minus sign down, and 2 times -2 is -4, 2 times -4 is -8. Okay, and then I just did 6 minus -4, 6 minus -8. So that ends up being 6 plus 4, 6 plus 8, 10, 14. You don't have to write all those steps. You can do this in your head. You really can. All right, so that's how the graph should have been. And what I did on this one, I just graphed the original one, 2, 2. I graphed that. Okay, so that's vector u right there. And then the second one was -2, -4. That was vector w. I didn't really do the scalar on this, but if you did the scalar on this, then what you would do is sketch out 6, 6. So that would go over 6, up 6. So basically what happens is that vector stretches out. And what happens to this one is this one also stretches out by a factor of 2. So this would be left 4, down 8. So this vector would end up going down kind of like this. All right, and then you get the vector going out this way. So over 10 up 14, I just ran out of room. Okay, all right, those problems are real simple to do. Graphing, again, I wanted you to do that to make the geometric connections of what it means to add and subtract vectors. All right, so that'll close that off in a real short video. So shouldn't have any problem with this. Good luck.